Hello and welcome. My name is Terry Moreno and you are in my channel Embedded Soul. I'm an electronic engineer and develop C-language programming focused on embedded systems. And this channel has been created to share knowledge about this topic. I hope you enjoy the content and please leave your comments. But don't forget to click on the like button if you like this video and subscribe if you like this channel. Thank you for watching.
Hello and welcome. In this video, we are going to talk about C language linked lists. We'll talk about theory, types, and their implementation. Let's talk about the theory. Linked list is an abstract data structure. A data structure is a way to organize data, variables. Linked list is a group or set of variables connected with them. Every set of variables are called nodes. Every variable inside a node is called an element. All the nodes are composed by the same elements. It means all the nodes can store the same number of type of variables. Well, imagine we have boxes. Inside those boxes, we have some variables, like a file characteristics of a node. And we want to connect to the next node because it is a sequence of data. Then inside this box, we can have a link to connect to the next node. At the end, it's a list of variables connected between them. Okay. Continue. All the nodes are connected because at least one of their elements is appointed to the next node. We can create a linked list, a single linked list, that they are linked lists connected each other in one direction. It means each node knows how to connect to the next one, but not to the previous one. It goes in one direction. You know how to connect to the next box, one box to the next box, but not with the previous one. And a double linked list is a node that can connect with the next one and the previous one. It's bidirectional. Okay, if one node connects to more than one following node, then the linked list is called a tree. Trees are one kind of linked list. They can be binary trees, 2 elements after each node, or they can have more than 2 elements, 3, 4, etc. The linked lists are dynamic. The length of the linked list can increase or decrease as necessary. This is the reason because it's used when the programmer doesn't know the number of elements expected on the linked list. We will allocate memory on the heap for each node. This is the reason because it can increase and decrease the number of nodes as needed. Because we're going to allocate memory on the heap, and we can allocate 1, 2, or the elements what we need. And we can free the memory, so we can increase the number of elements of the linked list, or we can decrease those elements, the number of elements. The nodes can contain different types of variables, including other structures, but all the nodes will contain the same variables. I mean, each box it has the same types of variables that the next box. Why? Because the variable that link or connect to the next box is going to be a pointer, and that pointer has to be expressed what type of variable is going is pointing. So the next point has to be declared as a pointer to a node. Okay, so the nodes are have to be the same type. We can use other resource to create a pseudo-linked list. Okay, something can think, okay, I can create an array, and inside an array, I can define each element as a structure, and all the structures are going to be nodes, and those nodes are connected because inside the array has an index. I'm pointing or incrementing or decrementing this index. I can point to every structure inside the array. And you are right, you can create a pseudo-linked list using array. It's an easy way. It's more easy to use arrays, but it has its disadvantages. Or we can look at memory in the heap for a number of nodes. Okay, we can allocate memory in the heap, and for the number of bytes, multiplicate by the number of nodes we want to allocate there. But the most disadvantage here is when you want to increase or decrease the number of elements or reallocating memory on the heap, the processor has to look for a space to put consecutively all the nodes, all the elements. So it has to look for a big space to locate all the memory, and it has to copy the elements from the previous location to the new location. And it spends a lot of time. Well, you can create the text explanation here. Continue. Advantages of using linked lists. Well, I talked about it. They are allocated dynamically. We can increase and decrease the number of nodes, saving memory space. It's not necessary the nodes be contiguous in memory. We can take the most of the gaps in memory space. It doesn't not use the stack memory managed by the microprocessor. In embedded systems, the memory stack is more limited than the heap. Disadvantages of using linked lists. They are a bit more complicated to manage here. We have to deal with the pointers and manage them. The nodes are not contiguous in memory, so we can access to the next node incrementing the current pointer by the number of bytes that compound the nodes. Well, they are going to be a bit more complicated, but they are more powerful to use than arrays or allocating directly memory on the heap. Types of linked list. We can create stacks, queues, and trees. Let's see. Let's see them. A stack. A stack is a type of linked list where the program will add nodes, but when the program wants to recover the nodes, it gets the last one that was introduced. Okay, this example I put here is when we are cooking pancakes. Imagine you are cooking the first pancake. You have your pancake on the pan, and you take out the first pancake and put on the plate. The first one is going to be at the bottom of the stack, because the first one is the first you remove from the pan is the first one you put on the plate. The next pancakes you are going to cook, and when you remove them, you are going to put over the first pancake you remove from the pan. So when you finish cooking, the last pancake you take out from the pan is on the top of the stack, you know? And when you're going to eat them, you're going to take the first one on the top of the stack that is the last one to take off from the pan. Do you understand? I hope so. This is known as LIFO, last input, first output. The last pancake you introduced to the stack, to the pancake stack, is the first one to take for it. I hope it's clear. Queues. This linked list works in the way that the first node introduced on the list is the first node that will be taken out from the linked list. And here the example is when a group of people is waiting in line for the checkout in a grocery store, for example. The first person that was introduced in the queue, in line, is the first one to be served by the checkout. Is it busy? This is known as FIFO, first input, first output. Okay, I think it's very clear. Trees. A tree is a kind of linked list where each node links to more than one next element. Example, when we classify animals, for example, they can be vertebrates and invertebrates. Inside the vertebrates, they can be birds, fish, mammal. Inside the invertebrates can be arthropods, echinoderms, mollusks, etc. Okay, every classification is split in all the classifications and so on, and again and again. In this way, the linked list is not represented by a line because each node has more than one link. The path branches again and again in the way if we perform the nodes and the links, we'll draw a tree. Okay, let's see a draw example. Okay, stack and queues. We have our nodes represented for these boxes. Inside the boxes, we have different variables, and at the end, we have a pointer to the next box. If we manage a stack or queues, the representation is linear because it's a sequence, one box contiguous or rear another box. But we want to represent a tree. Each box or each node has more than one pointer to a next node. In the way that the link are like branches or the node branch in this case in two nodes, and those node branches in other two nodes, and so on. If we turn this draw, we can see a kind of tree. Okay. Implementation. How are we going to implement a linked list? Okay, the elements, the variables inside the nodes are going to be grouped inside the structure variable. Or we'll create a structure. Inside the structure, we'll declare the variables we want to store, and each structure is going to be our nodes. If we are working with a stack or a queue, one of the elements inside the node will be a pointer to the next node, and this pointer is going to be a pointer to a structure node type. Okay, we want to point to another node, and this node is in a structure type. So the pointer has to be a pointer to a structure node type. If we're working with a tree, more than one element inside the node will be a pointer to a next node. Okay, in the next videos, we'll show some examples using IDEs to show how to implement a linked list, and I hope it'll be useful for you. Thank you for watching.